You can use ProcGLM to verify the ANOVA assumptions and perform the ANOVA test. ProcGLM fits a general linear model, of which ANOVA is a special case. ProcGLM also displays the sums of squares associated with each hypothesis it tests. Here's the ProcGLM syntax and the program for your analysis. In the ProcGLM statement, you specify your SAS dataset mg_garlic. You add the plots equals option and specify only to suppress the default plots in ProcGLM. You request diagnostics plots and specify unpack. This means that SAS puts each plot on a separate page. Otherwise, you will see all of the plots in a grid or panel display. In the class statement, you specify the classification variable for the analysis. This is your predictor variable, fertilizer. In the model statement, you specify the variables as indicated in the ANOVA model. Bulb weight equals fertilizer. The means statement computes unadjusted means, or arithmetic means, of the dependent variable bulb weight for each value of the specified effect. So, the mean statement computes the average bulb weight for each type of fertilizer. You can also use the means statement to test the assumption of equal variances. To do that, you add the HOV test option, which is the homogeneity of variance test option. This option performs Levene's test for homogeneity of variances by default. If the resulting p-value of Levene's test is greater than some critical value, typically 0.05, you fail to reject the null hypothesis of equal variances. Here's a question. What is the purpose of the quit statement in the code? ProcGLM supports run group processing, which means that the procedure stays active until SAS encounters a proc, data, or quit statement. Run group processing enables you to submit additional statements, followed by another run statement without resubmitting the proc statement. How will you verify your analysis of variance assumptions? The first ANOVA assumption is satisfied because fertilizers were randomly assigned to plots in an appropriate manner. You can use diagnostic plots of the residuals in ProcGLM to verify the assumption that the errors are normally distributed. And you can use Levene's test for homogeneity in ProcGLM to verify that the variances are equal across the fertilizers. The GLM procedure also produces a plot of residuals versus their predicted values, the group means, to visually verify the equal variance assumption.